Hello everyone. In our last class, we discussed about the carbon and the possibility of bond formations by carbon atom and ground state electronic configuration of the carbon and excited state electronic configuration of the carbon we discussed. And today we are going to discuss about hybridization concept. What is hybridization? Hybridization is nothing but the redistribution of orbitals of almost equal energy in individual atoms to form equal number of new orbitals with identical properties like energy and shape is called hybridization. The concept of this hybridization was introduced by Linus Pauling, scientist. The concept of hybridization was introduced by Linus Pauling, scientist. According to Linus Pauling, scientist, hybridization is defined as the redistribution of orbitals of almost equal energy in individual atoms to form equal number of new orbitals with identical properties like energy and shape is called hybridization. This concept was introduced by Linus Pauling, scientist. If we discuss about carbon, in our last class, we had seen two types of configuration. One configuration is carbon at ground state and carbon in its excited state. When the carbon is in its ground state, the electronic distribution will be 1s2, 2s2, 2p2, 2p2, and we can arrange electrons in the degenerate orbitals. This is the ground state electronic configuration of the carbon. In excited, this is ground state electronic configuration. Ground state electronic configuration of carbon. What happens in excited state electronic configuration? 1s2, 2s2, 2p2. This is excited state electronic configuration of carbon. Excited state electronic configuration of carbon. In excited state electronic configuration, what is happening? One electron from 2s2 is in its excited state jumping from 2s2 to 2p. So in that way it becomes 2s1, 2p3. One, two, 3. So in excited state electronic configuration, carbon have 4 unpaired electrons, that is 1s, px, py, pz, 2px, 2py, 2pz. So in excited state electronic configuration of the carbon, there are 4 unpaired electrons. In that 4 unpaired electrons, 1 electron is present in the s orbital and remaining 3 are present in 2px, 2py, 2pz. So here 1s, 1, 2, 3, 3p orbitals are there. How many? 3. So we pronounce this as sp3. sp3. In excited state electronic configuration of carbon, we have seen that 4 unpaired electrons are there. So carbon can involve in sp3 hybridization. Carbon can involve in sp3 hybridization. In that sp3 hybridization, 1 s orbital and 3 p orbitals are participating, or 1 s orbital and 3 p orbitals are reshuffling their orbitals to form equal number of hybrid orbitals is called hybridization. And we will discuss with examples for sp3 hybridization and sp2 hybridization and sp hybridization with the carbon atom. First we will consider sp3 hybridization. sp3 hybridization. sp3 hybridization can be seen in methane. sp3 hybridization can be seen in methane. As already you all know that carbon atomic number is 6 and in its electronic configuration 2, 4. That 4 is nothing but the electrons present in the outermost shell is 4 electrons. So according to Levy's dot structure we will give 4 dots. And how many hydrogens are there? 4 hydrogens are there and each hydrogen atomic number is 1. So it forms 4 covalent bonds. 4 covalent bonds. It is the structure of methane, already we discussed in our last class, and the bond angle between the carbon and hydrogen atoms here is 109 degrees 28 minutes. This is the bond angle in methane. And how in this methane the orbitals will reshuffle to form hybrid orbitals, we will see the structure of methane. So in that way we have dumbbell shapes and 4 hydrogens are involving in hybridization process. 1 hydrogen here, here also 1 hydrogen sharing their electrons. So this is the structure of methane. So in the structure of methane, it is forming how many bonds? 1, 2, 3, 4 bonds. So these 4 bonds are end to end overlapped. So we call that kind of bonds a sigma bond. Sigma sp3 s. So your sp3 is nothing but 1 s orbital from carbon and 3 orbitals from also from carbon, and this s is from hydrogen atom. In that way, we can observe 4 sigma sp3 s. Here also sigma sp3 s. Here also 4th bond sp3 s. In that way, we can observe 4 covalent bonds between the carbon and 4 hydrogen atoms. So this is the structure of methane, which is involving sp3 hybridization. Next to sp2 hybridization. sp2 hybridization. So sp2 hybridization is nothing but it takes place in ethene. sp hybridization takes place in ethene and its chemical formula C2H4. C2H4 is the chemical formula of ethene. Here already we know that carbon electronic configuration 1s2, excited state electronic configuration 2s1, 2p3. This is S, 2px, 2py, 2pz. Here it is involving in sp2 hybridization. So only one s orbital, 2 p orbitals will involve in the hybridization process, and this 2pz cannot involve in hybridization, and it is called sp2 hybridization. So after hybridization, what happens? In definition itself we discussed the redistribution of orbitals of almost equal energy in individual atoms to form equal number of new orbitals is called hybridization, and the newly formed orbitals are called hybrid orbitals. So here we get hybrid orbitals. How many? 1, 2, 3. This is nothing but sp2 hybrids. So in sp2 hybridization, 1s and px py, 3 hybrids we can find. That is 1s 2p orbitals. Total sp2 hybrids we can find. What about this 2pz? It is present aside. That means this jet 2pz is not involving in the hybridization process. So its energy is different, its shape is different compared to the hybrid orbitals. Generally, in definition itself, we discussed that hybrid orbitals have same shape and same energy according to hybridization concept introduced by Linus Pauling scientist. And we will discuss the structure of this ethene molecule. So in our previous class, we discussed that in ethene molecule, 2 carbons are present. Around the carbon, according to Lewis dot structure, we have to represent 4 unpaired electrons and 4 hydrogens are there. These 4 hydrogens, by sharing electron, form covalent bonds with the carbon, each carbon atom. 2 hydrogens will share the electrons. In the previous case, we had seen all are single bonds in the case of methane. Here it is ethene. Here we can see 1 double bond and 4 single bonds. That means carbon with its tetravalency, that means 4 unpaired electrons in their valency shell, it can form 4 single bonds. At the same time, 1 double bond, 2 single bonds. It can form single bonds and double bonds also. In the next example, we will discuss triple bond also. So in this way, we can see the structure of ethene. Same structure if we apply, and we all know that the shape of the px orbital, py orbital, pz orbitals are dumbbell in shape. And if we consider this as px orbital, and this is py orbital and pz orbital, total 3 p orbitals. But how many carbons we have? 2 carbons. So we have to consider one more carbon, that is second carbon. So it also have px, py, pz orbitals like this. So here px of first carbon is overlapping with the px of second carbon, and here it forms sigma bond. Sigma sp2 sp2. Sigma sp2 sp2 bond we can observe. This is the first bond formed between ethene molecule. And how many hydrogens are there? 4 hydrogens are there. How many? 4 hydrogens are there. So these 4 hydrogens will mix here. 1 and 2. This side also 1, 2. So here we can see 1, 2, 3, 4, 5. 5 bonds. And what about the 6th bond? 6th bond is nothing but it forms between pz, that is lateral overlapping. By lateral overlapping, it is nothing but it is pi bond. Pi bond is the very weak bond. So here we can see total 6 bonds. 6 bonds are present in ethene molecule. Out of these 6 bonds, 5 bonds are sigma bonds. 5 sigma bonds we can see. Sigma bond is nothing but it is very strong bond and formed due to overlap, that is hybridization of end to end of orbitals between the individual atoms, and 1 pi bond we can see. 1 pi bond. In ethene molecule, we can see 6 bonds. Out of the 6 bonds, 5 sigma bonds and 1 pi bond we can observe in ethene molecule, that is C2H4. And this is the structure of ethene according to sp2 hybridization, how the individual atoms are redistributing their atomic orbitals. Next example, sp hybridization. sp hybridization can be seen in ethyl. Chemical formula is C2H2. Chemical formula of ethyl is C2H2. So here also if we see 2s1 2p3 is the ground state electronic configuration of carbon atom. So here also we can find 4 unpaired electrons. Among these 4 unpaired electrons, one s orbital, one px orbital will involve in hybridization process. Remaining p 2py 2pz they cannot involve in hybridization process. So after hybridization, that means here sp only involved in the hybridization process, px py pz. After involving into the hybridization process, we get 1 2, that is nothing but this is sp hybrid, sp hybrid, this is sp hybrids, and remaining 2, these 2 are not involving in the hybridization process. So for sp hybridization, the example is ethyl C2H4 is the chemical formula. Only s orbital and p orbital involve in hybridization and form sp hybrids, and 2py 2pz cannot involve in bond formation, that means hybridization process. If we see the structure of this ethyl according to hybridization process, we have 2 carbon atoms. So in 2 carbon atoms we have 1s, 2px, 2py, 2pz, and that means 4 unpaired electrons are present. So we will represent after hybridization all will get in same shape and same energy. So we are going to take the dumbbell shapes. This is first carbon atom, one more carbon atom we have. So we can represent that carbon atom like this. Here end to end overlap takes place and partial overlap also takes place. So here if we consider, means this is sigma bond formed by sigma sp hybridization. This is how many hydrogens are there? 2 hydrogens are there. So 2 hydrogens will mix or combine or involve in hybridization to form new hybrid orbital of one hydrogen with one carbon and second hydrogen with second carbon. So here also we can see sigma sp hybridization. Here also we can see sigma sp hybrid. 1 2 3. 1s and 2p orbital. 1s and 1p is involved in hybridization process here. What happens to the py and pz? The py and pz, this is py. Here we can observe pi py hybridization. Sigma py bond we can see, and on the z axis pi pz. So a partial overlapping takes place between py and pz. Only s and p will involve in hybridization process. So this is the structure of ethyl, and in ethyl we can see sp hybridization.